Hi, everyone, and welcome to AstroNights Live. Once again, we have a fascinating presentation planned for you, and we're very excited that you chose to spend a little of your time with us tonight. Our presentation will be about 20 minutes in length, after which we'll be able to address a few of your questions. Those of you participating on Zoom can post a question via the Q&A window. Be sure to hold your questions to the end because it just might get answered during the presentation itself. If you're joining us via YouTube Live, you should know that Q&A is not available, so just sit back and enjoy. Whether you are joining us on Zoom or YouTube Live, we recommend taking a moment to locate the full screen mode in your app to get the best AstroNights live viewing experience. All of the websites and resources we'll be discussing during our program will be available on our website. So don't worry about writing anything down. Just relax and enjoy the program. The links will be there waiting for you whenever you're ready. I'd like to say a special good evening to everyone. My name is Mary McDonald, and I am the Planetarium Program Manager at the Christa McAuliffe Center at Framingham State University. And for the past 5 months, I have been your host for AstroNights. But I'm very excited tonight to introduce you to my colleagues who are going to be leading the presentation today. So joining us tonight as your hosts are Brenna Quirk and John Sheff. Both have been working with us at the McAuliffe Center for about a year now. Brenna is the Planetarium Program presenter, which usually means that she's presenting shows in the Dome, but she is now excited to be part of our virtual programs, including AstroNights. John is usually a flight director with the McAuliffe Center, and he's also a lifelong amateur astronomer and space buff. As a NASA Solar System ambassador, John has a particular passion for planetary exploration. John regularly teaches popular astronomy courses at the Cambridge Center for Adult Education, among other things. So that is all for me today. I am going to turn it over to my coworkers and your hosts tonight. And I believe that, like previous AstroNights, we're going to start off with a question for the audience. So everybody enjoy AstroNights tonight, and take it away, Brenna and John.
All right, thank you, Mary. So I wanted to start off with this question tonight, which is, which places in the solar system have humans been to? So it might be more than one of these answers. It might be all of them. It might be none of them. Hopefully it's not none of them, though. So the options we have are Earth, the Moon, Mars, and Venus. So just take a minute if you are watching with someone else to discuss what you think the answer might be. And if you are watching on Zoom, I'm going to be launching this question as a poll. So you should have the poll up right now if you're watching on Zoom, so you can actually enter your answers. It is multiple choice in case you want to pick more than one answer. And I'll just give you maybe 30 more seconds to talk with the people you're watching with and choose your answers. All right, so if you're on Zoom, I'm going to give you 10 more seconds to get your answer in on the poll before I close it. All right, so it looks like everyone has voted for Earth and the Moon, which is great. We have been to those places. We're on Earth right now, so that one's good. And a couple people also voted for Mars, perhaps because that is the topic of our show tonight. But actually, human beings have not been to Mars yet. So far, we've only sent robots to Mars. And actually all of the exploration that we're going to be talking about tonight is still just going to be robots that we're sending to Mars. But we are hoping that someday in the future we will be able to send humans to Mars. So I want to get started by taking a look at our sky tonight. So I'm going to go ahead and pull that up. All right, so now we are looking at our sky tonight at about 7:15 p.m. Facing towards the west, you can see the sun is just about to set. And I also want to point out the moon, this thin little crescent right here. It's pretty hard to see, a little bit easier to see in real life. So new moon was actually on Tuesday, so that's why it's just a very thin crescent today. But now I'm going to go ahead and run time forward so that we can set the sun. And as the sun sets and it starts to get a little bit darker, you'll be able to see the moon just a bit easier right there. All right, so now it's actually getting dark enough that we can see some stars. So once the moon sets, I'm going to pause time at just about 8:45 tonight. And I want to turn to look in the southern sky. All right, so here we are facing south, and there are three bright objects in the sky over here that I want to point out. So we have this one right here, which you probably noticed right away. It is the brightest thing you see over here. We have another bright object right here next to it. And then if you look towards the west, there's this bright orange object right here. So if you've been tuning in to our previous AstroNights this summer, then you already probably know what those two bright objects are on the left. Those are Jupiter and Saturn. So the two largest planets in our solar system, they're really great objects to look at in the night sky right now because they are very bright in the sky, and they're also visible not too long after sunset. And now the third object, this orange one, I wanted to point out this object because a lot of people see something orange in the sky, especially if they're thinking about Mars and think that they are seeing Mars, but this is actually a bright star. It does appear red like that in the sky, but this is a star called Antares. Now the name for this star comes from the Greek for rival to Ares, Ares being the Greek name for Mars. So this star really is not Mars, and its name tells you that. So if you do want to see Mars, though, you'll have to stay up a little bit later into the night because Mars hasn't actually risen in the sky by 8:47 p.m. So I'm going to turn us around to the east because things rise in the east and set in the west. So if we want to catch Mars rising, we should be looking towards the east. But before I do run time forward again, I actually just want to point out a couple of constellations that you can look for in the sky while you're waiting for Mars to rise. And one of them will actually also help you find Mars once it does rise. So if you look in the east right here, you should see these four bright stars that form pretty much a square shape. So I can actually go ahead and connect these. And these four bright stars form something that we call the Great Square of Pegasus. Now, that's actually not a constellation. It's something that we call an asterism. So it's just an easy to recognize group of stars in the sky. But we call it the Great Square of Pegasus because it is part of a bigger constellation called Pegasus. So this is Pegasus right here. And when Mars does rise, it is going to be below Pegasus in the sky. So if you are trying to find Mars, you can find Pegasus first, and that should help you out when you are trying to find Mars. So now let's go ahead and run time forward again. So once Mars does actually rise in the sky tonight, it is going to appear very bright. And actually, as we move into the fall, it's going to start appearing even brighter and brighter, and it will start to rise earlier in the evening. Now, there are two reasons why a planet would appear very bright in our sky. So before I tell you, I'll give you a couple seconds to think about that. Maybe talk with anyone that you're watching with. What are the reasons why a planet would appear very bright in our sky? All right, and then I'm going to stop time at 10:45 because Mars has risen above the horizon. There it is. So, okay, I'll tell you the two reasons that a planet would appear very bright in our sky. Either it is very big, like Jupiter and Saturn, or it is close to us. So Mars is not very big. I can actually show you, compared to Earth, how big Mars is. All right, so I've just put up this photo. You can see there's Mars next to Earth. They are not this close in real life, but this is just to show you the size difference between them. So Mars is pretty small. It's bigger than Mercury, but it's the second smallest planet. So that's not the reason that Mars is going to appear very bright. So that must mean that Mars is going to be pretty close to us. And it actually is. Mars is approaching something called opposition. And what that means is that while the sun will be on one side of the Earth, Mars is going to be on the opposite side, so opposition. And when Mars is at opposition, that is actually when it's at its closest point to Earth. And that also means that it will be visible in the sky throughout the whole night, so from sunset to sunrise. So Mars opposition is a really great time to see Mars in the sky. Although I do just want to clarify that when I say Mars will be close to us, close in space is not really what we think of as close on Earth. So Mars will still be about 36 million miles away from Earth at opposition. So just to give you some perspective on that, if you wanted to drive your car to Mars at opposition, it would take you about 70 years to drive that distance. So still far away, but closer than usual. But now I want to take a look at the Mars opposition from a different angle. So now we are looking down at our solar system, at the inner solar system, and these lines here represent the orbits of the inner planets. So this is Mercury, Venus, Earth, and Mars, and we actually have the planets themselves labeled for Earth and Mars. And this is their positions today around the sun. So Mars isn't at opposition yet, it's just getting close to that. So I'm going to jump forward a month. And as I jump forward, you can see that Earth moved. So Earth is moving this way around the sun, and Mars is also moving in that direction around the sun. But you can tell that Earth is actually kind of catching up to Mars. So if I go forward one more month, so now we're in October. October 15th, this is actually 2 days after the exact opposition, but this is really close. You can see we have the sun on one side of the Earth. And then on the exact opposite side of the Earth, we have Mars. And you can see that the distance between the Earth and Mars is also closer now. If we go back to now, that distance, and then compare it to this distance in October, they're closer. And so this also actually can be a good way to visualize why Mars will be up throughout the entire night when it is at opposition. So when we're on Earth, if we're facing the sun, that means that it's daytime. And if we're facing away from the sun, that means it's nighttime. So in this case, when they're exactly opposite each other, turning away from the sun means turning towards Mars. So as soon as the sun sets, Mars will rise and it will be up throughout the whole night. All right, now like I said, Earth and Mars, they're going to be much closer than they usually are when Mars is at opposition, which also makes it a really great time to launch a mission to Mars because the trip will be relatively short. So I'm actually going to hand it over to John now to give you guys a little bit more information about the mission to Mars. John, if you want to go ahead and share your screen.
Thank you. Let me get my PowerPoint started. Okay, so the question may arise, why explore Mars? Why is Mars such an interesting place? Well, a few reasons, but the main ones are, there's a field called comparative planetology. I know those are big words, but it's basically comparing planets to see what is the same and what is different. And by exploring Mars, we can help ourselves understand the geology and climate of Earth and other planets. And given that climate change is happening so quickly here on Earth, I think it's desperately important that we figure out how planets work. Climate change has happened on Mars as well as on Venus. In fact, the first signs of the greenhouse effect, which causes planetary warming, was discovered on Venus. Is there life on Mars? That's another question. Mars used to be a warmer, wetter planet. We know that there was liquid water on the surface, a requirement that all living organisms on Earth have. It doesn't mean there is life. It just means there could have been life. Finally, we're studying Mars in preparation for human missions. Someday humans will go to Mars. NASA is planning that. Other nations are planning that. Even private organizations like SpaceX are planning that. So sooner or later, it's going to happen. And before we send humans there, we need to know as much as possible about the environment they'll encounter. Here is a map of all the landing sites that have already happened and will happen. The ones in blue, like Viking 1 here, are places where spacecraft have landed in the past. The ones in red, like this one and that one, are places that are targeted for landings in the near future. So Mars 2020 is the old name for Perseverance. So this is where Perseverance is going to land. Also notice that there are sites for Tianwen-1 here and here. That's a Chinese lander mission that's on its way to Mars. And basically the reason there's two of them is because they haven't yet decided on what the landing site will be. There's also about 6 operational orbiters in orbit around Mars. So there's a lot of action going on. NASA's Perseverance mission was launched on July 30th, 2020, and it's going to reach Mars and land next February 18th. The landing site has been chosen to be Jezero crater. And here you see a color-coded map of the crater. These are not the real colors that you would see with the eye, but these are delineate different features of the landscape. So this dark red area is the crater floor, and this is the crater wall, this blue area. Now, you might notice over here, there's an inflow channel where water used to flow. And it used to flow right down the rim of the crater and form this delta. And the reason this landing site is so interesting is because on Earth, we know that deltas are a great way to preserve organic materials and even living fossils of living things for long periods of time. This green-yellow circle, by the way, is the target ellipse for where Perseverance is aimed to land on Mars. We also have something cool that's a technology demonstration. It's gonna be there's gonna be a Mars helicopter. Let me see if I can get this going. Okay, I think it will. It's called Ingenuity. And it's merely a technology test. It's not meant to be a real crucial part of the mission, but flying vehicles like this may in the future become a very useful tool to explore Mars. Now you have to remember the Martian atmosphere is very thin. It's the same as 100,000 feet above Earth's surface. That's way too thin for an aircraft like a passenger jet to fly. But this rover is very light, and it has the rovers spin very rapidly, so it can fly for short distances on a Martian surface. Another new technology demonstration that I should mention is that there's going to be a microphone on Perseverance, and during the landing and afterwards, it'll be turned on, and we may hear for the first time the sounds of another planet. Perseverance is the first step of 3 missions that will ultimately return Mars samples to Earth. Perseverance won't return the samples to Earth, but its job is to gather them and put them in little vials, so a future mission could grab them and gather them up and launch them into space. So that's envisioned to be something like the sample return lander, with a rover that goes out to fetch the samples that Perseverance gathered, and then take off and shoot them into orbit around Mars. A follow-up mission shortly thereafter is going to rendezvous, it's going to meet up with that spacecraft in orbit around Mars, grab the sample package, and return them to Earth. That's probably going to happen around 2031 if all goes well. And I should mention that there have been other launches to Mars this year. Hope is a Mars orbiter, launched by the United Arab Emirates, a country in the Persian Gulf area. And Tianwen-1 is launched by China, and it's an ambitious mission. It consists of an orbiter, a lander, and a small rover. So we'll have to see how that goes. And this is a picture of Mars from the neighborhood of Earth from the Hubble Space Telescope. And with that, I think I'll stop talking, and maybe we open it up to Q&A.
Thanks so much, John. Yeah, so everyone, remember that if you are joining us on Zoom, you can enter your questions in the Q&A, which should be at the bottom of your Zoom window. So I'm actually going to really quickly take a moment to share, because I want to remind everyone of our website, which we did mention at the beginning of the program today. So the main website for the McAuliffe Center is cmcenter.org, which I should be sharing, right? Yes.
I don't, oh, there it is.
Okay, there we go, everybody. So by the way, while we're taking a quick look at this, just everyone, now's the time to enter your questions in the Q&A window. But yeah, so here's the website for the McAuliffe Center, cmcenter.org. Couple of things I want to direct your attention to on the front page. We do have a button that gives you some simple instructions to donate to support our programs, which is much appreciated at this time. But also all the programs that the planetarium has put together, such as AstroNights, can be found under From the Dome to Your Home. So that's where you'll find everything that we've curated for you. There is a whole section for AstroNights, and on that page you'll find a separate event page for each event. So pretty soon, as soon as, you know, now we're pretty much all back from vacation, we'll put up all of our upcoming events once we've got those planned out pretty soon. And here's tonight's page. So we did put a lot of great resources here, especially about the Mars 2020 mission, which I'm sure some of you are interested in learning more about. So, John, do you think you could go back to that lovely Mars image just so we have something nice up?
Sure.
And in the meantime, I'm going to take a look at the Q&A. Oh, we got some great questions coming through. All right. So, let's see. I'm going to take the first question here. I'm going to direct it to John. The question is, does the helicopter on Mars have a camera?
The answer is yes, it definitely does. It doesn't carry too many scientific instruments, but it does in fact have a camera. So we will be getting some shots from that.
That's cool. Yeah, so it doesn't have much, but camera, yes. So I mean, you got to put a camera on everything. It's just, okay, next question. I'm gonna direct this one to Brenna. Have humans found evidence for life on Mars? And I'm gonna just add, including, we know humans haven't been there, but all of the robotic missions and every other way we study Mars, has any evidence of life been found?
Yeah, so that is a really good question. We haven't yet found concrete evidence of life existing on Mars, but we have found evidence, like John mentioned, that there used to be liquid water on Mars, which we know is a really important factor for living things. So that gives us the idea that it is possible that there was life on Mars in the past, or that maybe there is life on Mars now. So the Perseverance mission that's going to be collecting samples is really looking for signs of organic material, so more signs of life. And hopefully we'll get those samples back and we'll be able to take a closer look at them.
I'm going to ask you one more, Brenna, just sort of a follow-up that I see here. Do we know why the water dried up on Mars?
Oh, that is a good question. I don't actually know off the top of my head if we know that. John, do you know?
From what I've heard, basically, Mars being smaller than Earth, as Brenna pointed out in her presentation, it's cooled off more rapidly than Earth, and its liquid core, which generates a magnetic field, probably just cooled off and turned solid. And without a magnetic field to protect the atmosphere of Mars from solar particles, the atmosphere has been swept away gradually because Mars does not have the protection of a magnetic field. That's my understanding of it. So the atmosphere is just too thin right now to allow liquid water to exist on the surface, though it may be underground.
Great answer. I always love to point that out, that whenever we think about can liquid water exist on the surface, we always first think of temperature, like is the temperature correct? But there's also this idea of atmospheric pressure. So for water to be liquid, it has to be not only the right temperature, but also the right atmospheric pressure. So we really don't know if Mars has enough atmospheric pressure to maintain liquid water for any amount of time. Great answer. All right, now another one to you, John. I love this question. I hope, I don't know, I'm curious about it. So the question, and I'm gonna read some of these names, by the way, this is from Jennifer. What sounds are NASA anticipating to hear on Mars?
That's a great question, Jennifer. So what we're gonna learn for sure, what we're gonna hear is the sound of the orbiter as it's going through the Martian atmosphere and from the lander, and the shields separating, the parachutes popping, and probably actually the gentle bump onto the surface. Once on the surface, we're also going to hear things like motors as the rover moves, we'll hear clicks from other parts of the mechanism. And what we're really hoping, although this isn't for certain, is that we'll hear the wind. The wind on Mars does exist, and but we've never actually heard what it sounds like. So maybe we will.
Okay, interesting. Yeah. So I'm going to go next to a question from our dear friend, Pat Monteith, who I'm so pleased is with us. The question is, and I love this question, this is going to make a lot of people happy. John, can you talk a little bit about the oxygen making machine, which is an experiment that I think is really neat? Do you know about that one, John?
Yes, I do. There's an experiment on board that's going to take some of the Martian atmosphere, which is mostly made of carbon dioxide, and split the atoms of carbon away from the atoms of oxygen and gather and store the oxygen, just to see if it can be done. Because in the future, when explorers go to Mars, they can't take everything they need with them. The space mission, the spacecraft would just be too heavy. So we're gonna do a little living off the land. And if we can make our own oxygen and use the resources of water that already we know exists on Mars, at least in the form of ice, then we won't have to carry oxygen and water with us other than to get there during the trip.
All right, great answer. John, do you happen to know which university developed that experiment?
I'm sorry, I don't know.
I'm happy to say it's MIT. So,
oh,
yeah, I always like to give a Massachusetts connection.
Well, Mary, hi, this is Irene.
Oh, hi.
I actually intervened because, yeah, the team of Moxie is the name of the experiment. Well, it's not just a team at MIT, it's a team of researchers with whom we are connected. And we are developing, we hope, some future presentations about that specific project. So, yeah, no, we are especially excited to see what Moxie is going to do in this mission.
So many unique things in this mission. Okay. Who's up next? Let's see. I have a question from G. Davis. Was it a coincidence? We may not know. I'll send this one to you, John. Was it a coincidence that 3 missions to Mars were launched last month?
It's not a coincidence at all. In fact, as Brenna mentioned, near opposition, when Mars is every 26 months, a little every 2 years, Mars is approaches close to us, and there's something called a launch window of about 2 or 3 weeks when you can launch something to Mars with a minimum amount of rocket fuel and energy and money expended. And you can also make your payload very heavy. So it just so happens that the launch window for the current opposition of Mars began in July, and I think ran through the first week of August. That's why all 3 were launched. In fact, there's another European mission called ExoMars, which is being developed as a rover, but it had some problems, and particularly in tests of its parachute, there were some problems there. So it's been delayed till 2022, which is the next launch window. So spacecraft tend to get launched during the launch window when it's optimum path to get to Mars.
All right, and the next question I'm gonna send to Brenna. This one's from Jack Walker. Can you tell us, why does Mars sky appear orange?
Yeah, so that one is actually interesting. The reason that the sky appears orange on Mars is really because the surface of Mars appears pretty orange, which is actually because of the iron on Mars. It's rust, basically, that makes it appear orange. And so the dust from the surface of Mars gets kicked up into the atmosphere. There's a lot of dust storms on Mars. And so you're actually, when you see the orange sky of Mars, you're seeing the orange dust being suspended in the atmosphere.
Cool. Okay. I have one more question I'm going to ask. I think I'll give this one to John because you put up this picture. And the question's from Susan. And I'm going to read it exactly as it's written, but do we know what that white colored storm is from the current Hubble view? So I think she's probably referring to the white patch at the bottom, which may or may not be a storm. So can you tell us a little bit about that?
Sure, it's not actually a storm. Mars, like Earth, has polar ice caps in the south and the north. And this is the southern polar ice cap that we're looking at here that you mentioned. Kind of does look like a cloud for sure, but it's actually a region where water has frozen into ice, and also even some of the carbon dioxide from the Martian atmosphere froze onto the surface. So every Martian winter, one of these gets really big and the other one gets smaller. In this case, we're going to have winter in the northern hemisphere right now. You can't see the polar cap, but this is the one in the south, which is smaller than you would normally see it if it was winter in the south. I hope that answers your question.
All right. And then I think I will just take, since we had so many great questions today, thank you everyone for sharing these questions. I will go with the last one that we have here, which is from Olivia, and it is, how come humans haven't gone to Mars yet? John, you want to take that one?
Sure. Actually, technologically, we're pretty ready. We could do it within the next few years if we wanted to. We've solved most of the problems involved in sending humans to Mars, but it's a question of expense. Such a mission would be extremely expensive for any country or organization to undertake. And also politically, I mean, a lot of people wonder whether spending money on something like sending humans to Mars is really the way we should be spending money. I happen to think it is, but it's a matter of convincing other people as well. So maybe looking at our little presentation will give somebody some thought.
All right, well, that's a great way to wrap things up. I want to remind everyone to check out our website. We have lots of great resources from this event page about the Mars 2020 mission, as well as other general things about Mars and more. And check back there in the next couple days for upcoming AstroNights events. Now I want to just wish everyone a wonderful weekend, and we hope to see you at future AstroNights events. Have a good night.